Has it ever occurred to you that an asteroid could strike the Earth one day with disastrous consequences? Whatever you answer, some of the most brilliant minds today are preoccupied with how to help humanity cope with such a disaster. One of them is Elon Musk, and he is taking his own steps to ensure humanity survives such a catastrophe. However, NASA has been pondering the same problem and even sounding a warning of a possible cosmic collision with an asteroid. To prevent such an occurrence, NASA is working on a system known as DARTS. What is DARTS, and how will NASA use it to stop asteroids from hitting the Earth? Join us as we dive into how NASA's chief gives a severe warning about an asteroid hitting the Earth. Asteroids. Huge space objects that films have popularized to cause wanton destruction when they strike the Earth. But is it true asteroids can strike the planet? Before answering the question, it is important to know a few things about asteroids. Asteroids are rocky objects revolving around the Sun that are too small to be called planets. They're also known as planetoids or minor planets. There are millions of asteroids ranging from several feet to hundreds of miles across. The mass of all the asteroids is less than that of Earth's moon. Asteroids exist primarily within 3 regions of the solar system. Most asteroids lie in a vast ring between the orbits of Mars and Jupiter. This belt houses more than 200 asteroids larger than 60 miles or 100 kilometers in diameter. Scientists estimate the asteroid belt also contains between 1.1 million and 1.9 million asteroids larger than 1 kilometer or 3,281 feet in diameter and millions of smaller ones. However, it is not everything in the main belt that is an asteroid. For example, there is Ceres, once thought of only as an asteroid but turned out to be a dwarf planet. In the past decade, scientists have also identified a class of objects known as main belt comets, small rocky objects possessing tails. While some of the tails form when objects crash into an asteroid or by disintegrating asteroids, others may be comets in disguise. Asteroids are actually old objects. They are leftovers from the formation of our solar system about 4.6 billion years ago. Early on, the birth of Jupiter prevented any planetary bodies from forming in the gap between Mars and Jupiter, causing the small objects that were there to collide with each other and fragment into the asteroids seen today. Nearly all asteroids are irregularly shaped, although you might find a few of the largest that are roughly spherical, such as Ceres. They're often pitted or cratered. For example, Vesta has a giant crater some 285 miles or 460 kilometers in diameter. As asteroids revolve around the Sun in their elliptical orbits, they rotate, sometimes tumbling quite erratically. More than 150 asteroids are also known to have a small companion moon. Some even have 2 moons. Binary or double asteroids also exist, in which 2 asteroids of roughly equal size orbit each other, as do triple asteroid systems. Near-Earth asteroids, or NEAs, circle the Sun at about the same distance as Earth does. These objects are subcategorized based on how the asteroid's orbit compares to Earth's. For example, Amur asteroids have orbits that approach Earth's path but remain exclusively between Earth and Mars. Apollo asteroids have Earth-crossing orbits but spend most of their time outside the planet's path. Astronomers also classify certain near-Earth asteroids as potentially hazardous asteroids, or PHAs. These rocks come within about 4.65 million miles or 7.48 million kilometers of Earth's orbit and are larger than about 500 feet or 140 meters across. Scientists have discovered more than 27,000 near-Earth asteroids. Of these, just under 10,000 have diameters larger than 500 feet. So, are we really in danger of a collision with an asteroid? The short answer is yes. Ever since Earth formed about 4.5 billion years ago, asteroids and comets have routinely slammed into the planet. An asteroid that is more than a quarter of a mile in size is capable of a global disaster. Researchers have estimated that such an impact would raise enough dust into the atmosphere to effectively create a nuclear winter, severely disrupting agriculture worldwide. Smaller asteroids can destroy a city or cause devastating tsunamis. Space rocks smaller than 82 feet or 25 meters will most likely burn up as they enter Earth's atmosphere. In 2013, an asteroid slammed into the atmosphere over the Russian city of Chelyabinsk, creating a shockwave that injured 1,200 people. The space rock is thought to have measured about 65 feet or 20 meters wide when it entered Earth's atmosphere. The question is, how can we protect the Earth against a possible future deadly strike from an asteroid? Or are we helpless and just wait to see whatever damage an asteroid in a collision course with the Earth will do? Elon Musk has hit on transforming planet Mars into a habitable environment. He reasons that a part of humanity should start living on Mars so they survive in case of an asteroid accident that wipes out humanity on Earth. He thinks a community of 1 million people on the red planet can be self-sustaining. He is even building a spacecraft that will take his volunteers to Mars. However, Musk's plan requires billions of dollars and incredible technological advancements to actualize. While Musk's plan involves getting out of the path of a possible incoming asteroid, NASA's solution takes the fight to the asteroid as it approaches. The solution is known as DART, or Double Asteroid Redirection Test. How does DART work? It's simple, or at least on paper. Sometime in late September or early October of 2022, the 1,210-pound or 550 kilograms DART spacecraft will slam into a small asteroid named Dimorphos, changing the space rock's orbit around its larger companion, Didymos. Astronomers will quantify that change, gauging the effectiveness of the kinetic impact method of asteroid deflection, a strategy NASA plans to employ in the future against a rock that lines Earth up in its crosshairs. This technique works particularly well if used far in advance, since small nudges can add up to big changes later on. DART is the first space mission to test this or any other asteroid deflection technique. The DART probe launched from Vandenberg Space Force Base in California late November 24th, riding a SpaceX Falcon 9 rocket. The DART mission team members have checked out the spacecraft's various systems and its main scientific instrument, a camera called DRACO, or Didymos Reconnaissance and Asteroid Camera for optical navigation. You just have to bear with NASA with its abbreviations. DART is a relatively small spacecraft. Its core consists of a box barely a meter wide on all sides, with two rollout solar arrays that give the spacecraft a width of about 12 meters or 40 feet. DART's electric propulsion system generates a flow of charged ions to create a gentle but continuous push. The DART spacecraft carries NASA's evolutionary xenon thruster commercial NEXT-C engine, developed by the agency's Glenn Research Center and the aerospace company Aerojet Rocketdyne. NEXT-C is a solar-powered ion propulsion system that could find its way onto future spacecraft. It's not DART's primary propulsion system, as the probe uses 12 hydrazine thrusters to make its way toward the Didymos-Dimorphos pair. However, NEXT-C will get a key in-space test during the mission. The spacecraft will loop around Earth multiple times using its electric thruster to gain the speed needed to escape orbit. From there, it will head to Didymos, possibly flying past another asteroid named 2001 CB21 on the way. The action will ramp up considerably as DART nears its target. DRACO will capture its first imagery of the Didymos system 30 days before impact. Those photos will help the probe refine its course toward Dimorphos. Then, 10 days before impact, DART will deploy a tiny Italian spacecraft called LICIACube, which will zoom past Dimorphos just after the collision to observe its immediate effects. Those effects could be quite striking, given that DART will slam into Dimorphos at about 15,000 miles per hour or 24,000 kilometers per hour. The impact will occur when the Didymos system is roughly 6.8 million miles or 11 million kilometers from Earth, the closest the two asteroids get to our planet on their elliptical path around the Sun. And that's no coincidence. The timing allows scientists to make higher quality telescopic observations of Didymos after the collection. The last time Didymos was this close to Earth was in 2003. The next time will be in 2062. Observations of Didymos and Dimorphos will continue well into the future, and not just from afar. A few years from now, the European Space Agency plans to launch a spacecraft called Hera, which will journey to the Didymos system to get an up-close look at the damage DART did. Didymos and Dimorphos are particularly well-suited targets for DART. They are relatively small. Didymos measures just 780 meters or half a mile across, and Dimorphos measures only 160 meters or 525 feet across. But they pass in front of each other as seen from Earth. Optical ground-based telescopes see them as a single point of light that fluctuates in brightness as Dimorphos circles Didymos. The interval of those fluctuations will change after DART's impact. Additionally, Didymos and Dimorphos do not come close enough to Earth for DART to send them hurtling towards our planet inadvertently. The DART project cost $324.5 million. $308 million was spent on spacecraft development, $68.8 million for launch services from SpaceX, and $16.5 million is expected to be spent on operations and data analysis. DART will crash into Dimorphos at a speed of 6.6 kilometers or 4.1 miles per second. The impact should change Dimorphos's orbital period around Didymos from 11.9 to 11.8 hours, a difference of just 4.2 minutes. This will pull Dimorphos slightly closer to Didymos. Let's hear what you think of an asteroid hitting the Earth in the comments section below.